بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today I'm going to introduce the Feastal decryption and how this Feastal decryption is transformed from encryption to decryption. How the data is moving and to prove that the data in the encryption is exactly the data is out of the decryption phase. Means we are using the same algorithm for encryption and the same algorithm for decryption. I'm going to prove that the data, for example, for each level, we are going to get the same data output. For example, at this level, we have LE14 and RE14. We can prove that LE14 is exactly to RD2 and RE14 is exactly to LD1, LD2. They are exactly the same bits. This mean this means that Feastal encryption decryption algorithm is reversible. We can use the same algorithm in encryption and decryption. And that's what I'm going to prove in this lecture. I will take this example step by handwriting right now, and I will show you how to prove this part. So I will share my camera. I will share my camera here from advanced camera. Yes, now I think you should see the same Feastal uh, block, the last rounds here, round 15 and round 16, and then going back from round 1 in the decryption. This is encryption and this is decryption. This is why D refers to decryption and E refers to encryption. And also we have L, which is left, and the R, which is right. And the number here, the subscript, is the subscript for the round. So LE16 means the left-hand side of encryption cycle of encryption, round number 16. And here we find K, which is K16, which is the subkey number 16, and the function F. And here we have a block of XOR that takes the input from the function and the input from the LD0 and make an XOR between them to produce RD1. Now I want to prove the if I can prove that the output here is the same output here, I prove that this function is reversible. This function is reversible means encryption is the inverse of decryption. We can do the same cycle, we apply the same rounds and get the same data output as we have seen with XOR. So this is the same as saying, okay, we have seen as XOR here we have 1 0 1 0, and this is the key and this is the data. For example, we have here 1 1 0 0. So if this is the data, we go to make an XOR at the sender. So this is XOR, this is 0 1 1 0. And I take this 1 1 0 and move it to the receiver and use the same key. The same key is used to together with the received data, and apply the XOR again 0 0 1 1 to get the data back. This is the data, and this is the data, exactly the same data back. We can say that the XOR is, we can reverse, we can use the same operation here. The XOR is the operation of encryption, and the XOR is the operation of decryption, and that's why we say that the feastal cipher, feastal structure, feastal structure is also reversible, means we can use encryption and decryption using the same algorithm. Now we go to the proof part. We go to the proof part. We prove that the data here is the same as the data here. Here we have data, for example, 10001, for example. I will find it is the same 10001, the same data exactly. So how to prove that? We take we draw the last round here. It is here. I will draw it again. So we have LE15 and RE15, and we have the K16 here, and this is F, and this is the XOR. To get the output from the XOR, I take LE15 together with the output from the function and XOR it to get RE16. RE16. Here I have RE15 is swapped, just swapping the position. So this is LE15, 16, sorry. Now I have my structure, and then this swap means this is encryption. Encryption. In the decryption, I do the same thing. Here I move. This is what means this one will come here. This last swap means the right hand side will be the left hand side there, and the left hand side will be the right hand side there. This means this is the right hand side will be in the left hand side. So here we have RE16, we have LD0, we have RD0. Also the same thing, we are doing the same here. We are doing like that. Here we do like that. From bottom up, this is from top to bottom. RD0, we pass RD0 to the function F using the key 16, then move it to XOR and get the RD1. Here we take the output from LD0 and XOR it directly with the output from function F, and then RD0 is swapped directly without any change to LD1. Now I want to prove here LD1 and RD0 is exactly RE15 and LE15. I want to prove that LD1 is LE15 and RD1 is RE15. Or sorry, like the opposite here. So I want to prove that RE15 is LD1, or LD1 is RE15, and RD1 is LE15. I want to prove they are the same. If I prove they are the same, this means they are having the same value. Now we move to say LD1, this one. LD1 is exactly LD1 is exactly RD0, which is exactly LE15, LE16. Okay, and RD1 is exactly RD1 is LD0 XOR the output of the function f of LD0. Sorry, this is LD0. RD1 is LD0 XOR the function of K 16 and RD0. Okay, these functions, I'm writing the same thing here, just I want to these two functions, number one, sorry for covering, RD1 LD0 XOR F K16 RD0, and this is the second function. I want to reduce this function to get LD1 to get RE15. This should be RE15, and reduce this one RD1 to get LE15. I take them one by one. I take LD1, LD1. LD1 is RD0. Okay, I will take this first. LD1 is RD0, which is LE16, which is RE15. Okay, now I prove the first one. I proved it because RE15 LD1 is exactly RE15. That's no problem. Now we get to the difficult part. What about what about L? What about RD1? RD1. What about RD1? RD1 is equal to what? RD1, as I told you, LD0 XOR F K16 and RD0. And we understand now why is that. But I go to LD0, I found it RE16. RE16 is what? RE16 is the XOR of something. So LD0 is RE16 XOR, I just change LD0 to be RE16 XOR F K16 and RD0. Now RE16, I get it with XOR. All this is XOR, like some saying that LE15 XOR LE15 XOR of the K of K16 and RE15. All of this XORed with F of K16 and RD0. Okay, now this is the same as saying RE15, and here I have RE15 and this is RD0. RD0 is the same as LE16. So and LE16 is RE15. So I can remove RD0 and put RE15. This one becomes like that. Becomes like that. LE15 XOR LE15 XOR K of K16 and RE15, and then XOR what? XOR F of K16 and RD0. I can remove RD0 because I know RD0 is the same as RE15. So I say RE15. Now, the final step. I have now something XOR something. Something XOR something. If we have XOR and we have the left hand side of XOR is the same as the right hand side of XOR, this means the output is 0. So LE15 XOR 0. LE15 XOR 0, the output depend on LE15. If LE15 is 1, so the result is 1. If LE15 is 0, the result will be 0. So now the result is LE15. LE15 means we have returned the, we have get the exact left hand side of encryption. So now we have proved that RD1 is exactly LE15. So now we proved the second part. This is the proof, how to prove in the Feastal cipher, this level data in this level is the same data as in that level. This level is encryption and this level is decryption. They have the same data. They have the same output exactly. Okay, and that's all for the proof. And I hope you understand the proof now. You have to try it yourself. You have to try it you have to use the handwritten and try it yourself to understand it more deeply. And thank you for listening to me, and good luck in the exam, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.